So, the graph of a continuous function has no breaks, holes, or gaps. You can trace the graph of a continuous function without lifting your pencil. Alright, so discontinuous functions are functions that are not continuous. It's the prefix dis. Okay, so you got types of discontinuity. I'm going to tell you the easiest one to recognize is jump. That's a piecewise. And y'all all know what a piecewise looks like. And you know even in an equation what a piecewise looks like. So if you see a piecewise, either a picture or equation, you know it's automatic jump because you're jumping from one piece to another, okay? These are the two that you have to really think about here is infinite discontinuity. And when I say infinite, what do you see present in that graph? Asymptote. That means there's an asymptote. Okay, removable means there's a hole somewhere in that line. Now, when you graph it on a graphing calculator, you won't see a hole, but that means there's a hole. There's some point on that line that it is not defined for, okay? And I'm going to teach you the difference between infinite and removable as we go in a minute, okay? But removable means there's a hole. There's a removed part from that function. Infinite, there's an asymptote. That means asymptotes go on for infinitely ever, don't they? That's why it's called infinite, okay? And we're going to be using these terms throughout this year. Alright, so on the back, we have 7 examples today. And then you're going to do your homework and call it a day. It says, determine whether each function is continuous at the given x value. If discontinuous, identify the type of discontinuity as infinite, jump, or remove. You say, okay, how do you do that? If you evaluate this function at that function and get an answer, does that mean it's continuous? If you get an answer. Yes. If you don't, that means it's discontinuous. That's how we're going to do it. So first thing we always do is plug it in. If I plug in x equals 2 here, would I get an answer? I don't see any fractions or any radicals that 2 would give a problem with it. So it should be continuous at that. So let's do that. So I'm plugging f of 2. Did I get an answer? I got 1 in it, so that means it's continuous, okay? That means it's defined for x equals 2. But look here, number 2, x equals 1. If I take 1 and plug it in, do I run into a problem? Yes. That's undefined, isn't it? So that makes it discontinuous. Do you see how to tell the difference? So that means it's discontinuous at that point. It's discontinuous at x equals, because it is not defined. Now, yes.
Is it only at 1 that it's discontinuous? Or
just at that 1, at x equals 1, it's discontinuous. That means it's not defined. Because continuous means that if you keep going throughout that function, there's no bumps in the road. Well, there's a bump right there at x1. That's why it's discontinuous. Does that make sense? Just at that one spot, it's discontinuous, okay? What now? Oh no, we ain't got talked about that yet. No, this is. I'll tell you the difference from removable. This is not removable. Removable is when you can factor the problem and cancel it out. That's how I remember. If you can remove it by canceling, it's removable. Can I remove anything? Can I get x minus 1 out of the problem? So this is infinite. That means there's an asymptote at x equals 1. Okay, that's the bump in the road. Is the asymptote.
So it's infinite because there's like no way to get rid of it.
I'm about to show you an example of removable in just a minute, okay? So discontinuous, and this is infinite. That's all you have to do. And what does infinite mean? No, there's a what? There's an asymptote at this part right here. X equals 1. There's a vertical asymptote right there. Does that make sense?
Ooh, that's how it's got a weird graph.
We're going to graph those in Unit 3. We're still in Unit 1 right now. Alright, number 3. Okay, when they give you 2, you got to do the first. You got to determine both of them. So I'm going to put, this is going to be x equals negative 3 over here, and x equals 3.
Why do we do that?
Because we got 2 points to check here. We got x equals negative 3, x equals 3. Now, by looking at it, guys, I know that both are discontinuous, aren't they? Because if I plug negative 3 in, what's negative 3 squared? 9 minus 9 is what?
0.
There's a situation there, isn't it? Zero's in the denominator. I only got to check the denominator. Plug in 3. 3 squared is 9. 9 minus 9 is? Is that a problem? Is that a bump in the road? Yeah. Now, so we can go and put them both discontinuous. Yes, hon?
For x equals negative 3, if you do negative 3 plus 3, that's a 0, and then the bottom is 0.
Yeah, even if that's what's weird, because up to now you think 0 divided by 0 is 0. If anytime 0 is in the denominator, it's a problem. Even though that does divide out to 0, you just don't want 0 in the denominator, okay? Alright. Now how to determine. Can you factor this on? So I'm going to come to the side and look at this. I'm going to factor it down to see what I got going on. Now, if I was to set, okay, I can cancel out which ones. Okay. Now watch this. If I happen to set these equal to 0, x plus 3, what would that be? X equals negative 3. So that is associated with that parentheses. You see that? That is associated with the other one. But do you see how I removed that parentheses? So this is what type of discontinuity? Removable. What type is this? Infinite. Because I couldn't remove that. But I removed that. That means there's a hole in the graph. At that, there's an asymptote here. Does that make sense?
So when it's removable, it means like you could actually go over.
Well, there's just a hole there. There's a gap in the graph.
It's not infinite.
No. This is infinite. I couldn't remove it. That means there's a vertical asymptote there. Does everybody see that? This is just an intro to this. We're going to talk about this all year. Alright. So I would put removable here. Infinite here. Number 4. First of all, you got a piecewise. Is it continuous? No. Is it piecewise? It's because it jumps from piece to piece. So this is discontinuous. And what type of? You don't have to think about it. Jump.
You don't have to show any more anything on those?
No.
Okay. That's an imaginary number.
Do y'all agree with Tyler on number 5? Because what's negative 3 squared? 9 minus 5 is? Square root of 4 is? So is it continuous at that point? Yes, because you got an answer. Does that make sense, Tyler?
Yeah, just blank out.
Mhm.
I forgot to square it.
So that's continuous. It does exist at that. So I'm going to put continuous. Hold on just a second. What now? No, because did you put that square root there, or was it already there? Alright, number 6. If I plug 2 in, 2 squared is? 4 minus 4 is? 0. Alright, so is it continuous at that point? No. Now, we're going to factor it to see what type that is. Alright, if I was to set these equal to, could I cancel out the x minus 2? Okay, which of these parentheses is x equals 2? associated with the first or second one? Second one. Did I remove that second one? So what type of discontinuity is it? Removable.
Would there be an infinite one too?
Yes, but we're not. That was not part, but that would be an infinite when x equals negative 2. But we only
You
look.
have to write them both down?
No, you just have to write that one for that one they give
If
you.
there's one removal, you just gotta say it's removable.
No, buddy. Like here, they telling you what point to focus on. X equals 2. Now, if they had x equals and x equals negative 2, then I would have to put the infinite for the other one. On number 7, I have two of them. X equals 4, x equals negative 4. If I plug 4 in, 4 minus 4, is that a bump in the road? So I'll put discontinuous. Bless you. Can I remove that situation? No. So that what type of discontinuity is that? Infinite. Now if I plug negative 4 in, negative 4 minus 4, continuous or discontinuous? Continuous. You can get a value. 2 times, I'm going to evaluate that. And I get 1, positive 1.
So do we have to evaluate it?
Yeah, if it's continuous, you have to evaluate it. How do you feel about your learning target today? I need a hand signal. Okay, you got 20 minutes to do 10 problems, page 27. I'm going to be sitting up here. If you need help with that, you come up here and ask me a question. Don't be scared to come up here. But no one's going, you go to the restroom. Is that what you want? Well, we're not ask every 5 minutes to go to the restroom right now, okay? So, we're good? You should get your homework done before. Come up here and say, Miss Chester, will you go back through that one more time with me? I will. Yes. Even if you get a square root of some crazy number, if you get an answer, that's continuous, okay? You can work in your group with each other too as well.